This is the last video for Chapter 3, and we're going to talk about scatter plots and lines of best fit. This is 3.6D, and all the previous videos for Chapter 3 are linked in the geometry playlist in the description. A line has an infinite number of points on it, and we can find the slope of a line if we can identify two distinct points on the line. So looking at this line, I drew in some of the points, but actually, if I could have used a smaller pen, there would have been a lot more points than this. Because a line is just an infinite amount of little tiny points. Okay? And the table shows several possible measures of an angle and its supplement. Remember, a supplement is 180 degrees. Graph the points given in this table. Then draw the line that best represents the data and write the equation of the line. So the first thing we're going to do is use the table to write ordered pairs. We're going to use x and 180 minus x because that's the value for y. You can see in the table we have our x values, and then y is 180 minus whatever the x value is. That means we're going to have 180 minus 30, so y is going to be 150. We're going to have 180 minus 60, so y is going to be 120. Okay, we write our ordered pairs. We use the table to write those ordered pairs, and we plot the points. We've got our graph here, and along the bottom for the x-axis, we've got it going by tens, 10, 20, 30, 40, 50, and same thing coming up for the y-axis. See? So we can plot 30, 150. Here's 30. Here's 150. We've got 1 point. We've got 60 and 120, that's right here. We've got 90, 90, that's right here. 120, 60, that's right here. And 150, 30, that's right here. We draw a line that passes through all the points. Now, for number 3, we choose 2 points from that line, like 30, 150 and 120, 60. 30, 150 and 120, 60. And you don't want to do 2 numbers next to each other because then the points are going to be really close together and it may be hard to draw an accurate line. The farther away the points are from each other, like this one and this one, you have a better chance of making a more accurate line, okay? We're going to use these coordinates in the slope formula to find the slope of the line. So here's our slope formula, and we've got our x sub 1, y sub 1, x sub 2, y sub 2. So we're going to do 60 minus 150 and 120 minus 30. We're going to get a negative 90 over a 90, which is a negative 1. So we know our slope, m, is a negative 1. Now we can use the point slope form to find the equation of the line and then simplify. So we know we've got 30 for x and 150 for y. We know our slope is a negative 1. And we need to distribute this negative 1 into the parentheses. So we've got a negative x plus a 30, because this negative and that negative make a positive 30, don't they? Now we can add 150 to both sides of the equal sign, because we're going to solve for y. That creates a 0 pair here, and we have y equals negative x plus 180. And the equation of our line is y equals negative x plus 180. If we can draw a line through all the points in a set of data, the relationship is linear. If the points are close to a line, we can approximate the relationship with a line of best fit. So maybe the points on the line are a little, crooked, and it doesn't quite make a straight line, but we can do a line of best fit. A physical therapist evaluates a client's progress by measuring the angle of motion of an injured joint. It's going to be his wrist. And the table shows the angle of motion of a client's wrist over 6 weeks. So our x values are the weeks, our y values are the angle measures that he can turn his wrist, bend his wrist. We're going to estimate the equation of the line of best fit. We use this table to write ordered pairs, and we plot the points. We plot 1 for x, 30 for y. We plot all of these, and look at the line that it made. It's not quite straight, is it? This one's kind of sticking out. We use a ruler to estimate a line of best fit and try to get the edge of the ruler closest to all the points on the line. So we got kind of close. That one is sticking up a little bit, but that's okay. It's definitely going through this one and this one, isn't it? So a line passing through 2 for x, 36 for y, and 6 for x, 62 for y seem to be the closest to all the points. Now we can use these 2 points to find the slope of the line. We use the slope formula. So we've got our x sub 1, y sub 1, x sub 2, y sub 2. So we've got 62 minus 36 over 6 minus 2. We do our math, we get a 26 over a 4. That simplifies to 6.5. 4 times 6 is 24 with 2/4 left over. That comes out to 6.5. We use the point slope form to find the equation of the line and then simplify. So we know our slope is 6.5. We can put that in. And we know our first ordered pairs are x sub 1, y sub 1. That's a 2 and a 36. So our equation looks like y minus 36 equals 6.5 times x minus 2. We have to distribute this 6.5. So we get 6.5x minus 13, because 6.5 times negative 2 is a negative 13. Now we can add the 36 to both sides of the equation to solve for y. And we get y equals 6.5x plus 23. Now we did this in 8th grade. And if you want to see the Grade 8 Math Chapter 14 playlist, it's not really that long, but it talks a lot about trend lines and outliers and scatter plots. Our next video is going to be Chapter 4. We're going to be drawing and identifying transformations in 4.1a. So that's it for Chapter 3. We're going to move on to talking about triangles and congruence, and keep up the good work. Have a great day. Hit the like button if you can, and I'll see you next time. Bye.